Problem 4. 3 apples, 4 bananas, and 2 pears cost 63 kroners, while 3 pears, 5 apples, and 6 bananas cost 97 kroner. How many apples can you get for 120 kroner? Okay, in case you're not Norwegian and wondering what kroner means, that's the local currency here in Norway. This is quite an interesting problem because you might have seen problems like this before, but this one is posed in a slightly different way. Where oftentimes you'll be given something like how much does it cost to get 1 apple, 1 banana, and 1 pear? So it's interesting that they said, how many apples can you get for 120 kroner? Let's write this one out. So this is a classic problem where you have 3 equations and 3 unknowns, right? You have 3 different fruits where you need to where you're given information about that. So I always like to do that, just write down the information in a systematic way. So let's say that we're saying that apples are A. Let's make A, B, and P for pear. And I'm going to make a little line up here. I'm going to write down the information that I'm given in the form of equations. So 3 apples, that's going to be a 3A, and then plus 4 bananas. Write that better. 4 bananas, 4B. And then we have 2 pears, 2P equals 63 kroners. And then we have 3 pears and 5 apples and 6 bananas. There we go. That equals 97 kroner. So, of course, how many apples can you get for 120 kroners? So that means that we have to find out the price for 1 apple. Now, oftentimes at this point, it can be pretty obvious that you can just subtract one equation from the other and then be left with what you're being asked about. For example, the cost of 1 apple or 2 apples, and then you just divide that by 2, right, to get the price per apple. Doesn't look like that we have that here. So let's see if there's something else that we can find. So we have 3 apples and 4 bananas and 2 peas. And so if I were to subtract the second equation from the first one, for example, I would be left with 2 apples, 2 pears, and 1 pear. 2 bananas rather, and 1 pear. That wouldn't really help me that much. So what is it that, what's the key thing here that we need to do? Because, there has to be some way. Well, if you're used to adding and subtracting equations, you know that that's fine, right? As long as you put those in a way where all the terms are lined up, it's totally fine to take one equation and add that to the other or subtract from the other. Now, if you can do that, it should also be fine for you to, before you do that, multiply each term rather in an equation by some number. Right? If you were to multiply by 2 and then add, that's totally fine, right? And let's see if that is going to be helpful here. So, what I ideally want is to have the apples be isolated by themselves, and when I do a subtraction or addition, the bananas and pears to kind of cancel each other out. They when they add together, you get, or when they subtract rather one from another, you have none of them, right? So we're just left with apples. So let's see if we can do that. So what we're dealing with here is a 4 and a 6, and then a 2 and a 3. How can we go about doing that? Let me just make a line here. What is it that we can multiply this by? Well, 2 and 3. What can you multiply 2 by and 3 by to get the same number? Well, 2 multiplied by 3 gets you 6, and 3 multiplied by 2 gets you 6 as well. So that could be a way to do it. So let's say 3 here, and let's say 2 here. Now, of course, that won't work if that doesn't work for the bananas either, right? It's going to get messed up. Let's see if that works. 4 times 3, that's 12. 6 times 2, that's also 12, and it works. Turns out that this very conveniently does work for both of them. So that's what we can do. So let me now write the first equation here, or rather the second equation here, by multiplying it by 2, every term by 2. So that's going to give us 10 apples and 12 bananas and 6 pears. And it's going to be a 97 times 2. That's going to be what? That's going to be 180. And 7, that's 14. So that's 194. 194. That's the first equation. And then this one right here, we're going to write out by, multiplying it by 3 first. That's going to be 9 apple. Oh, love this, because then we're going to be left with 1 apple. Perfect. And then we have, of course, here as well, 12 bananas and 6 pears. And 63 times 3, that's going to be 60 times 3, that's 180. And then 3 times 3, that's 9, so that's 189. Okay. And then I'm going to make a line here, and then write a little minus so that we can subtract the second equation from the first one. It's going to be left with A. This becomes 0, this becomes 0, so we're left with this. 194, that's going to be just a 5, which means that an apple costs 5 kroners. We're still not done here, because they're having us do another step, which is how many apples can you get for 120 kroners, which of course is going to be super easy, because we can just do 120 divided by 5. Which, of course, I don't think I need to write this, because you probably already know that. But that's going to be, of course, 24. If you wanted to do it this way, you could do like 5 goes into 12 2 times, and then you get a 20, and then you have 4, so you get 24. There you go. 24 is the final answer. C is correct for this one. So for this one, the challenging bit was that there was an extra step involved here. Before you could do anything with the equations to isolate out what you're after, you had to multiply it by 3, the first one, and then the second one by 2. That's one way of doing it, of course. And then if you do that, it very conveniently just left you with 1 apple. And then they had you do another step, which is, do this little division. So a little bit of a harder problem with these, 3 equations with 3 unknown equations.